Alright, chapter 6.4, areas of a composite figure. We're going to be doing some of the same stuff that we've done before, but we're kind of going to add it all together. So I put a little piece of graph paper out here. You're going to have to find areas of composite figures. Okay, so before we did perimeter and circumference of composite figures, now we have to do area. And you have to know a couple of things. You need to know area of a triangle, and this is listed on page 263. And I guess it works better if I have this. Area of a triangle is 1/2 times base times height. Area of a rectangle equals base times height, or just length times width. This is L times W. And area of a parallelogram, which is similar to a rectangle, the area is base times height. And the reason they do base times height instead of length and width is because this is a width, but on this triangle the height is actually this line right here, or this line right here, or you could draw a line out here too. Anywhere it's the top, how far the top is from the bottom, and that's different than this length. That's a diagonal. Parallelograms have these diagonal edges, and it doesn't create the 90-degree angles that a rectangle has. So you can just do length times width on a rectangle, but you got to do base times height on a parallelogram. So it's something we've done before. You should know how to do that, but I just list them here real quick just for your knowledge, and you can see them on page 263. They've got you finding out length and width, etc., and they kind of build some little triangle here. And my numbers are going to be a little different than theirs, or actually my numbers may be the same, but it's not going to look as beautiful as theirs. They definitely took more time than I have. So we have this composite figure, and what we have is that we have a triangle right here. We have a rectangle right here and a parallelogram right here. So we've got to kind of work that out. The bottom of the parallelogram is 8 centimeters, but the height, which is a dotted line from the base to the top, is 6.7 centimeters. Okay, and here we have a rectangle whose height is 4.5, and whose top or bottom, length is 8 centimeters. And then we have this triangle, and the base of this triangle is 11.2. And so we have the height of the triangle because it's the same as the height of the rectangle. It's 4.5. We have all the numbers that we need to solve these, and basically we have to take the triangle. That looks like A. It definitely does. Triangle plus rectangle plus parallelogram to equal our area. So we have to find the area of each and add them together. If we just do that quickly, the area of this is area of the triangle is 1/2 base times height, which is 1/2 11.2 times 4.5. Hopefully you can see that. And then you just get your calculator out for that. And I've got one sitting here. If I clear it. 1/2. Now, the 1/2 is kind of cool. You can use 0.5 and multiply it, or you can do 11.2 times 4.5 and then divide by 2. So it's kind of like you can divide by 2 or you can multiply by 0.5. And hopefully you understand that. We've been working with fractions for a while, but right now I'm going to use 0.5 times 11.2 times 4.5. And that equals 25.2. Okay, and that kind of makes sense. If I were to multiply 11 times 4, I'd get 40. Or if I rounded 4 up to 5, I'd get 10 times 5 is 50. And I got half of that, and we should get half. 25.2 sort of makes sense. The second area, let me go back. This is our first area. I did it in orange. Second area, we'll do it in this blue color. Okay, and the area is just length times width, so it's just 8 times 4.5. Oops. And again, I guess you have to use calculators. You don't have to. You could do this longhand, but when the concept here, and they give us decimals, the concept here is to figure out, remember the formula, remember how to do a composite figure, and so I don't want us to get too distracted. Just use your calculator. 8 times 4.5. Oops. One more time. And I've got 36, and let's see if that's reasonable. 8 times 4 is 32. 8 times 5 is 40. And if we rounded 4.5 up to 5, and we just 8 times 5 would be 40. And it's smaller than that and bigger than 32, so that makes sense to me. Let's choose one more color, I guess red. For this one, the area equals base, which is 8 again, times height, which is 6.7. And again, all of these are in centimeters. And get the calculator out. 8 times 6.7, and you can do this on your calculator too. 53.6. In fact, you should be, if you can keep up. 53.6, and let's check that. 8 times 6 is 48, but if we rounded 6 up to 7, because 6.7 is almost 7, that'd be 56. So 53 makes sense. And we're going to just add all three of these together. This is like 36.0, so I add that 0 on just so that everything lines up. Okay, 6 plus 0 plus 2 is 8 tenths. 5 plus 6 is 11, plus 3 is 14. Got to carry that 1. And then 2 plus 1 is 3, plus 3 is 6, plus 5 is 11. So 114. And if I just went, 50, yeah, that's more than 100. 114.8 makes sense. So the composite area should equal 114.8. And that all makes sense. And you get to do the same thing on number 3 and on number 4. Number 3, I guess we skipped 1 and 2. Oh, it's shaded. Oh, let's go back and look at 1 and 2. That gives us one of these. And should I make it bigger? Move it over. Make it bigger. All right, that's probably good. All right, it gives us a shaded figure, and you just have to see what it's the area. So we got. Ooh, I should use my tool. You got a length here of 1, and the figure isn't exactly like this. Maybe I should make it a slightly different. So you have to check, because I might. If I do it exactly the same as them, then you're not having to figure it out for yourself. They have a figure that basically looks like this. And you have to figure the area of everything inside. And you might notice that this makes a square. Here, this part makes a, rectangle. And that this part here makes another rectangle. Hopefully you could do this quick enough for you to see it. So this is rectangle number 2. And then this little part right here makes a triangle. But what you can really do is you could probably do some estimating. Oh no, it says find the area of the shaded region. Area of a half square is half 45 squares. So we really are going to be estimating, because this sometimes the book is frustrating because these are not exactly half squares here. Half square we could add together to make a whole square, but there's one, this is most of a square, this is a little less than half, this is almost all, but we could kind of go through. And I guess what we'll do is we'll just mark the whole squares first. So we're just counting squares. 6, 7, 8, 9, 10, 11, 12, 13, 14, 17, 18, 19, 24, 25, 26, 27, 28, 29, 30, 41, 2, 3. So that's 43. And then we're going to kind of look at these, and I don't think we can really mark, this and this could be 1, this plus this could be another one, so that's 2, and this could be another one, 3, this and this could be another one, 4, but this is basically another one all by itself, and this is like a half a one. So I don't really know what they got. for number 1, and this is a little different than what you're going to get for number 1, but if I just look at it, 43 plus 1, 2, 3, 4, 5, that's 48 and a half, and I guess that's okay. You look at number 2, the diagonals actually are true diagonals. A true diagonal cuts each square. I guess let me find this again. True diagonal cuts each square right in half. It goes like this. Boom, and each square is cut right in half, where what we did here doesn't actually cut the squares exactly in half. So if you get an answer that's close, I think I'll let you get by with it. What you have to watch out for is that you'll have some that are half circles. You've got a square, and then you've got a half circle on each side of it, and you have my half circles are not going to be well drawn, but it's too slow for me to do it another way. And each one of these, it's a square, so it's 2 feet. This is number 4 I'm looking at. You've got what you've got is one square. So you have a square to add up plus a whole circle plus a whole circle, because there's 2 half circles that would make a whole circle and another 2 half circles that would make another whole circle. So you just have to find the area of this and the area of this and the area of this. Don't forget that the area of a circle is pi times the radius squared, pi r squared. So this is this 2 feet is the edge. It's 2 feet across this square, and so you're just going to do base times height, and this is 2 feet also. But for your radius, it's half of your 2 feet, so radius is really 1 on this one. R equals 1. What's r squared? 1 times 1. It's still 1. So then you just have to do 3.14 times 1. So really the area of this is length times width. You've got area equals of the square length, which is 2, times 2, which is height. Remember, the area of a rectangle is length times width. Area of a square is really just length squared, or width squared. But we don't need to remember another one. We can just use the rectangle one. It works anyway. So this is 4 feet. And it's 4 feet to the second power, because areas are always squared, plus our circle, which is, we just noticed that the area of our circle, let's see, the square is green, let's make the circle orange, and both of them are going to be the same. Area equals pi r squared. We notice that r squared is 1, so it's just 3.14 times 1. Okay, which is just equal to 3.14. So we have 3.14 plus 3.14. We end up with this all added together, and you can use a calculator for that. It's 4 plus 3.14 plus 3.14, and you should get 10 and 28 feet to the second power. Interesting how that works, but I think that's a good plan. Just got to keep working on it like that. The figures all have different shapes. You just have to kind of work it out. There's a couple, number 13, number 14, number 15, they're pretty tough, and number 16. And your teacher or myself will need to help you with that. Potentially, if you work real hard on it, I bet you could figure it out yourself. Everything's either half circles or triangles, and you just kind of have to work it out. Good luck with this lesson.